Thank you very much for giving me the opportunity of participating in this conference. It is a great pleasure and honor for me. And we're going to talk about social intelligence in machines, why and how. So first, we'll try to answer this question. Why are we interested in social intelligence in machines? Then we're going to see how we can achieve social intelligence in machines, and then a few words of conclusion. So, why social intelligence machine? And to do this, we first have to answer the question, what is social intelligence? And it is an ability to recognize and understand other people's moods, desires, motivations, and intentions. And this is the definition given by Garner, which was the originator of the theory of multiple intelligences. So essentially, it's the facet of our cognitive skills that helps us to be successful during social interactions. So why it is interesting to have social intelligence in machines? Well, for a very simple reason. If AI systems are indeed ever to walk among us, they'll have to be able to understand that each of us has thoughts and feelings and expectations, and they'll have to adjust their behavior accordingly. So essentially, social intelligence is seen as one of the last steps before artificial intelligence can really become part of our life, can really become something that we interact with every day. So now we can see how we can achieve social intelligence in machines. And to do this, we start with a game. So this is a picture, and I invite you to spend some seconds in answering this question. So what are these two people doing? Are they discussing? Are they exchanging ideas, etc.? And you can also pose to yourself another question. So what type of relationship these two people have? Are they friends? Are they colleagues, etc.? And in general, when I pose this question live, well, for what concerns the first question, what are they doing? In general, roughly 60% of the people say that they are fighting, they are arguing. Another 30% says that they are laughing, and then 10% suggests that they are singing. For the other question, what is the relationship they have, there is more consensus. 90% of the people think that they are a couple, they are partners. And even the remaining 10% talks about quite a close relationship. So members of the same family or very intimate friends. Now, the interesting aspect of the game is that there is no right or wrong answer. We do not know who these people are. We do not know what they say. We cannot see their faces. We cannot hear their voices. So how comes that we are so confident about a very high-level interpretation in terms of social and psychological phenomena? Well, the point is that our attention tends to focus pretty much on what people say, but there is a lot of nonverbal communication going on. And here you have examples of what we call nonverbal behavioral cues. And we, as humans, are very much sensitive to these cues. We sense them, we perceive them, and we interpret them collectively in terms of social signals. So in terms of the relational messages that people send to one another. So let me go a bit deeper into this phenomenon because it is crucial to understand how we can achieve social intelligence in machines. So when we talk about nonverbal communication, we talk about three main elements. The first are the nonverbal behavioral cues that we have just seen in the previous picture. And here you have a few examples, but there are so many nonverbal behavioral cues that psychologists group them together into 5 major classes. The codes. And this is the second important element in nonverbal communication. So we have physical appearance, the way people look like, we have face and head behavior, expression, movements of this type, etc. Voice behavior, which is everything in speech except word, is the way you say things. Gestures and postures, and we talk about the spontaneous gesture that someone shows when speaking, and the orientation with respect to the interlocutors, and then space and environment. For example, interpersonal distances, or the way we organize the space around us. And then there is the third important element, which are the functions. So nonverbal communication is a natural phenomenon, and everything in nature is there for a reason. And here are a few functions that the psychologists consider to be particularly important. So one is forming impression, right? This is the first time you see me, probably I'm trying to convey a certain impression. Expression of emotion, no need of an explanation. You are happy, you smile. Relational messages is what we have seen in the picture, right? Being friendly, being hostile, having a certain attitude with respect to others. Deception management, so being capable to lie credible and being capable to detect others when lying. And then power and persuasion, so being capable to show when we are above others and being capable to understand when someone else is above us. And so this is a very quick and general introduction to nonverbal behavior. The point is, what has this to do with technology? What has this to do with artificial intelligence? Well, it has to do under at least two main respects. The first is this one. What does it happen if we replace the person on the left with a machine that can display human-like behavior? So you can see here Furat, like the technological question is, can a robot, can Furat display nonverbal behavioral cues that somewhat fulfill the functions that we can see on the right part of this scheme, right? So can Furat look happy or sad, hostile, friendly, etc. And then the second point, the one we are going to focus on in this talk, is what happens when we replace the person on the right with a machine. And here the technological questions are, can that computer automatically detect nonverbal behavioral cues? And can that computer automatically interpret these cues in terms of the functions that are there? So for example, can the computer understand whether a person is happy or sad, whether it is hostile, friendly, and so on? And this is exactly what happens with computer. This is what we call to bridge the gap between the inner experience of that person and observable evidence that the person provides. So let's go to see a bit more in detail how this can work. We have our person here. The person, just because it is alive, is going to display some behavior, and we can capture that behavior with multiple sensors. Here we have a microphone and a camera because they are particularly common. However, you can imagine any type of sensor, from magnetic resonance that captures what happens in the brain to any type of wearable sensors that captures our physiology. The point is to capture the behavioral variance associated to social and psychological phenomena. People that have different inner experiences will produce different behaviors, different observable signals. And what the output of the sensor is are exactly these signals. Long sequences of physical measurements that can be extremely complex and involve a lot of different measurements, a lot of different numbers. And when we talk about numbers, the most, let's say, citable instrument to use is a computer. What a computer can do essentially is computation, is calculation. And so what happens typically is that we apply complex mathematical methodologies to process these signals and end up having something that we call distributions. We can think of this, it is a statistical approach that essentially gives us a map of the data in terms of how probable it is to observe a certain type of behavior, that for us it means to observe a certain value of a physical measurements when the inner experience of that particular person is X and Y. And what artificial intelligence does, in a sense, is to partition this variance according to social and psychological phenomena, to figure out how probable it is that we observe a certain behavior, for example, when the person is happy, or when the person is neutral, or when the person is sad. And from this point of view, anytime we observe some behavior, an AI approach is capable to tell us what is the probability that that corresponds to the person being happy, being neutral, being sad, or having any other type of inner experience, like having a certain intention, a certain attitude, having a certain personality, and so on. And this is the way, at the moment, we achieve social intelligence in machines. Now, let's maybe have a look at something that is very much interesting about this, which is what are the disciplines that are involved. When we think of the approach I've just described, we can see that essentially we have a number of methodologies that we use from a technological point of view. We need a lot of data. I didn't mention, but it can be really a large amount of data. And sometimes just storing, accessing, and processing this data, it is something that can be challenging. We have AI methodologies like deep neural networks or machine learning. These are statistical, mathematical methodologies that we use to process the data and do this work of mapping between variance and the inner experience of the person. We have signal processing and statistical data analysis. We start from data, we must be capable to process the data, to extract useful information from the data. And finally, to get the data, we need sensing approaches and infrastructure. And this is very much important because depending on how we sense behavior, then there will be things that we can do, that we can see, and things that we cannot do or we cannot see, right? And this is one part of the problem. And you see how everything starts with what? It starts with the data. Data is not just an input here. Data is really something that helps us to have the methodologies working correctly. So how do we get correct data? Well, first of all, we need to be capable to represent the inexperience of people, so social and psychological phenomena, in terms of constructs. So in terms of abstract representation that are actually citable for a scientific and technological approach. Then we need to know what is the relationship between these constructs and behavioral evidence. So we need to know, for example, that when you are happy, you tend to smile. Sometimes you do it, sometimes you don't, but it is more probable that you smile than you display any other facial expression. Then we have experimental design. When we want to obtain behavioral data, you have to put people in condition to display those behavioral data and to do it in a way that is consistent with their inner experience. So from this point of view, there has to be a good experimental and application design to ensure that people actually show their inner experience. And then, let's say, you have to know what are the neural and physiological traces of social and psychological phenomena. We insisted a lot on behavior, but part of behavior at the end is how our body reacts in terms of the neural processing of information and in terms really of our physiological changes. And it is at the intersection of these two big domains that somewhat we get what we call social artificial intelligence, or social signal processing, or affective computing, or artificial social intelligence. Let's say there are multiple names that go around this area. And what is interesting is that if you look at that intersection, it's not just intersection between different types of approach to the work, but it is really an intersection between two major fields. On the one hand, we have computer science and artificial intelligence, and on the other side, we have psychology and neuroscience. So somewhat the interesting point is that in order to give social intelligence to machines, you need to know about people as much as you know about machines. And from this point of view, it's really an interdisciplinary approach. So let me say a few words of conclusions. So I hope I showed you convincingly that what social AI does at the end is to bridge the gap between social and psychological phenomena, which is something that we cannot observe because it happens inside people, and behavior, which is something that we can observe, detect, and process with machines because it happens outside people. And data is not just an input, it is part of the approach, and it contributes to improve the effectiveness of AI methodologies. The domain is interdisciplinary, essentially, because we need to produce good data. We need to know about people and how they produce data in order to have good artificial intelligence. And finally, social AIs can give insight back about data, and from this point of view, it can help to better understand the social and psychological phenomena that we try to detect and analyze via artificial intelligence. So from this point of view, it is an interdisciplinary loop. Psychology helps AI, AI helps psychology. So thank you very much for your attention. In case you're interested to get some more information about these activities, I invite you to have a look at this website, which is the home of the Center for Doctoral Training in Social Intelligent Artificial Agents at the University of Glasgow. There you can see some more concrete examples of how we apply these methodologies to make machines socially intelligent. Thank you very much for your attention.